Hello everyone. In the previous video, we have discussed about the difference between fixed versus the dynamic na partitioning. So in dynamic na partitioning, as we have discussed, the memory allocation changes as the processes come into the memory or if the processes leave memory, right? So dynamic partitioning is also known as the variable partitioning or the dynamic memory allocation, and allows the system to allocate memory to process dynamically as needed. So for example, here process A needs to be executed. So it is only given a memory that it requires. Okay, and then B, then C, and then A is swapped to disk, or it leaves the memory, and so it can be replaced by another ready na process. And then B is done, and then A may be inserted in this unused na memory where B has left. Okay, now the question would be, how do we actually allocate the memory to processes? Okay, so one of this or three of these are first fit, best fit, and then the worst fit na algorithms. So these are memory allocation algorithms that are commonly used in dynamic na partitioning. So these algorithms determine how the system selects and assigns an available memory block to processes. So the first fit allocates the first hole. So you remember, right, that we have a main memory, and then we'll have several na partitions. So let's say a partition that is available, we can call that as a hole. All right. So for the first fit na algorithm, it allocates the first hole that is big enough. So it assigns the first na available na memory block that is large enough to accommodate a certain process. So the first available hole that it sees, then immediately, or that it sees and is also large enough for the process, then we select that hole. And it starts searching from the beginning of the memory and selects the first block that satisfies the process size na requirements. And for the best fit, on the other hand, it allocates the smallest hole that is big enough. Or in other words, it searches the entire memory and selects the smallest available block that can accommodate the size of the process. Okay, so its goal is to minimize the wasted space by choosing the closest na fit. So in best fit, we are searching the entire list unless ordered by size. So it produces the smallest leftover hole. And then for the worst fit, on the other hand, it allocates the largest hole. So in contrast to the best fit, the worst fit allocates the largest hole. And like the best fit, it must also search the entire list to look for the largest na hole. So for the worst fit again, it selects the largest na available na memory block or the largest hole for a process. So the goal of the worst fit, on the other hand, is to maximize the remaining na free na space, which can be useful for larger na processes. Okay? Yeah. So let's have a problem to understand all of these three na partitioning schemes or algorithms. Okay, so let us start with the first fit, but before that, let us read the problem. So given a memory partition of 100K, 500K, 200K, 300K, and 600K MB, in which these are in order, how would each of the first fit, best fit, and worst fit algorithms place processes of sizes 212, 417K, 112K, and 624K MB in order? And which algorithm makes the most efficient use of the memory? Okay, so let us start with the first fit. So as we have mentioned, this allocates the first hole that is big enough, first hole that it sees that is big enough, or assigns the first available na memory block that is large enough to accommodate a process. So as mentioned in the problem read earlier, we have a memory partition in this order: 100, followed by 500, followed by 200, 300, and then 600. And of course, we also have a space allocated for the OS. Now, if this is the definition of the first fit na algorithm, how are we going to allocate these processes P1, P2, P3, and P4 of sizes 212, 417, 112, and 426? Okay, so as we have mentioned, it starts searching from the beginning of the memory to the bottom of the memory. Okay, and it selects the first block that satisfies the size requirements. Now, does it fit, does P1 of size 212K fit in 100K? No. Next is it looks at partition 2. Does P1 fit in partition 2? Yes. So it will be allocated here. P1 will be allocated here. And the new size then, so since this is a dynamic na allocation, so from initially 500, so we now have an available space of 288. Okay, we simply subtracted 500 minus 212. So we have a new partition here, which has a size of 288. Now we have a process 2. Process 2 has a size 417K. Does it fit in 100K? No. Does it fit in partition 2 with 288? No. In 200K? Partition 3, also no. Partition 4 of 300K, also no. And it fits in partition 5. So we now have a new partition here, which has a size of 183K. So what we did was we simply subtracted 600 to 417K. So we have a new partition, 183. Now we have P3 of size 112K. So does it fit in 100 partition 1? No. In partition 2? Yes. So we will be assigning it to partition 2. And the partition 2 will now have a new size, which is 176K, since the 112K was allocated to P3. Now we have P4, remaining process P4 of size 426K. So does it fit in any memory block? So if we look starting from the beginning of the memory to the bottom of the memory, we can see that there is no such memory that would fit 426K. So what we are going to do is wait. So P4 must wait until a memory chunk fit for 426K is available. Okay, so do you understand now? Again, the first fit algorithm assigns the first available memory block that is large enough to accommodate a process. So advantages of the first fit is that it is relatively fast, as it selects the first suitable block encountered during the search. And it can also lead to better memory utilization compared to best fit and worst fit by reducing the some fragmentation. But the only problem is that it may leave small unallocated spaces between allocated na blocks. As you can see here, let's say in this partition, so it leaves some small unallocated na spaces. Okay, now what about for the best fit? The best fit is it allocates the smallest hole that is large enough to fit the process. So what it does is it also searches for the entire list unless ordered by size. Okay, so again, in other words, the best fit searches the entire memory and selects the smallest available block that can accommodate the process. So we still have this partition, same partition, and then we still have the same batch of processes. Okay, now where are we going to fit the 212K? So let's look for the smallest na process, smallest na partition pala, smallest hole or smallest available na chunk of the memory that can fit 212K. Partition starting from partition 1, so it's not available. The next smallest is partition 3 with 200K. Also not enough for P1 Next, the smallest is partition 4, which has a size of 300K. So we are going to put P1 in here, and it will dynamically take the difference, and we have left 88 na K here for other process to use. Next is the P2 of size 417K. Again, we must look for the smallest hole that can fit 417K. Let's look at partition 1, which is the the smallest is 88K. Partition 4, but it's not enough for P2. The next is partition 1, which is 100K, but also not enough for P2. The next smallest is 200K, partition 3, but also not enough for P2. Next smallest would be partition 2, which is 500K. So we are going to put the P2 in here. And we will have unallocated memory left, which has a size of 83K. Now, what about P3? So P3 has a size 112K. So where are we going to put 112K? So let's look for the smallest hole. So first would be the 83K. That's the smallest, partition 2, but that's enough for not enough for P3. Next is partition 4 of 88K, not enough for P3. Next would be 100K, and still not enough for P3. So next would be this partition 3. So we are going to put the P3 in here, and we will have 88K left. And lastly, we have P4 of size 426K. So what are the available holes? So partition 2 of 83K, followed by partition 3 of 88K, followed by partition 4, 88K, and we also have partition 1 of 100K. So all of these are not enough for P4. So next na smallest hole available is partition 5, and it would fit the P4. Okay. So yeah, we are going to put the P4 here, and we still have 174K left. So these are the memories available that we can still make use of. Okay, now what about the worst fit? So the worst fit, on the other hand, is searching for the largest na memory available for a process. So it allocates the largest na hole, and like the best fit, it must also search the entire na list for the largest na hole. Okay, so we still have the same partition, initial partitions, 100, 500, 200, 300, and 600. And then we still have the same batch of processes. Now let us start with P1. P1 has a size 212K. So as we mentioned in the worst fit, it selects the largest memory block available. So the largest memory block that we have here is partition 5, which has a size 600K. So we are going to put P1 here of size 212K, and we will have a new partition of 388K. Now we have P2 of size 417K, and where are we going to put the P2? So which is the largest hole here? The largest hole is partition 2 with 500K. So we are going to put P2 there, and then we will have the remaining 83K for partition 2. And then for P3 next of size 112K, we are going to put that in the next largest. So the largest available holes here, you look at the yellow. So the largest na available hole is partition 5. So we are going to put P3 in there, and we'll be left with 276K. And P4 of size 426K. So in this case, if we look at all the available na holes, the largest is only partition 4, which has 300K. So in this case, we cannot accommodate P4 yet. So P4 must wait until a memory chunk fit available for 426K is available. Okay, so that's it for this topic, and thank you for listening. And kindly comment if you were not able to understand anything.